this video, we are going to look at the double angle, the half angle, and the reduction, sometimes called the power reduction formulas for trig. So our first double angles that we have are the sine of 2 theta is going to be 2 sine theta cosine theta. Cosine 2 theta can be wrote 3 different ways. It can be wrote as cosine squared theta minus sine squared theta, 1 minus 2 sine squared theta, 2 cosine squared theta minus 1, and of course we get the tangent of 2 theta. You can find any of these without doing any work if you know your sum and difference. So the sine of 2 theta is the same thing as the sine of theta plus theta. If you then use the sum of the angles for sine, you will get this formula here. Similarly, if you use the fact that the cosine of 2 theta is the same thing as the cosine of theta plus theta, then of course you can get this first one here. If you replace cosine squared, so if you use the fundamental identity, the fact that cosine squared theta is equal to 1 minus the sine squared theta, then you're going to get that one. Similarly, if you use the fact that the sine squared theta is equal to 1 minus the cosine squared theta, you're going to get that one. To find the tangent of 2 theta, that's pretty straightforward. Again, you're going to do the tangent of 2 theta is going to be equal to the tangent of theta plus theta, and then you just use the sum of angles for tangent. So if I'm asked to evaluate these, to just simplify these, I look for pattern recognition. I see a 2 out front, and I see the sine and cosine are the same angle. So that means I must be using the sine of the double angle. So 2 sine theta cosine theta. This is 2 sine theta cosine theta type form. So this is just going to be the sine of 2 times 13. So in other words, the sine of 26 degrees. And that's as good as that one's going to get. I mean, I could put that in my calculator, but that's as good as it gets. Now I'm going to take a look at this one. I have a 2, the sine of an angle, the cosine of the angle. These angles match. So this is still just the double angle for sine. So I can rewrite this as the sine of pi over 9 minus pi over 2. And then that is going to be multiplied by 2. In fact, let me do it this way. Let me make it clearer. So I have 2. And then my angle is the same, which is pi over 9 minus pi over 2. Let's go ahead and just kind of clean this up a bit. So I'm going to go ahead and do the pi over 9 minus pi over 2. I multiply the numerator and denominator by the first one by 2, and the numerator and denominator of the second fraction by 9, and so I get negative 7 pi over 2. So this is equal to the sine of 2 times negative 7 pi over 2. Here you can see that this 2 and this 2 will cancel, leaving me the sine of negative 7 pi, which is, sine is an even, oh that should be, 18. Whew, I was getting all excited there and it's going to be a nice number. It's not. This is going to be 18, and so this is going to reduce to 7 pi over 9. As good as that gets. Don't drop the 18. And so this is going to be 7 pi over 18, not 2. So then all I can do then is do the fact that sine is odd, so it is negative sine of 7 pi over 9. And that's my final answer. I'm just going to leave it like that. Now I've got the 2 tangent 12 degrees, 1 minus tangent squared of 12 degrees. This matches the pattern for the tangent of 2 of my angle being 12 degrees. So this is going to be equal to the tangent of 2 multiplied by 12. So it's just the tangent of 24 degrees. And that's as good as that one's going to get as well. Now, if they're asking me to find the exact value of 2 times alpha, with the sine of alpha being 3/5, then I'm going to do like we did in the sum and difference. I'm going to figure out all of the x, y, r parts. So alpha in quadrant number 2. Alpha in quadrant number 2 means that I have the r value is going to be 5, the y value is going to be 3, And the x value in quadrant number 3 is going to be the square root of these. So 5 squared minus 3 squared, and it's going to be negative because we're in quadrant number 2. Now, just as a reminder, where did I get all this information? Well, the sine of my angle is 3 over 5. This is the y value over the r value. That's where I got the r and the y. The fact we're in quadrant number 2 means my x value has to be negative. So then my cosine of my angle, because I need sine and cosine for the double angle, is going to be equal to negative 4 over 5. So the sine of 2 alpha is going to be equal to 2, the sine of alpha, the cosine of alpha. The sine of alpha is given to me as 3 over 5. And then we just found the cosine of alpha, that's negative 4 over 5, negative 4 over 5. And so this is just simply going to be 2 multiplied by 3/5 multiplied by negative 4/5. So I have negative 12 times 2 is negative 24 divided by 5, and that is my final answer. Let's take a look at our next example here. So now I'm in quadrant number 3, and I want to find the tangent of 2 alpha. So as before, here's my alpha. On this one, I'm in quadrant number 3. So I'm given the sine of alpha as being in negative 4 over 5. That tells me my y is negative 4, and my r is always positive, and it'll be 5. That tells me my x, because this is a 3, 4, 5 triangle, is negative 3 in quadrant number 4. So then if I'm asked to find the tangent of 2 alpha, this is equal to 2, the tangent of alpha divided by 1 minus the tangent squared of alpha. My tangent of alpha is just going to be simply my x value over my y value. So this is going to be 2. My x value, my y value is negative 4. My x value is negative 3. 1 minus negative 4, negative 3 squared. My numerator is simply just going to be 8 over 3 because the double negatives will cancel themselves out. In my denominator, I'm going to get 1 minus 16 over 9. I'm going to go ahead and just multiply everything by 9. That will clear all my fractions. So I'll multiply the numerator by 9 over 1 and the denominator by 9 over 1. This will give me 8 multiplied by 3 in the numerator, and this will give me 9 minus 16 in the denominator. So I end up with 24 over 7, negative 7, and that is my final answer. Now let's take a look at my last example here. We want to find the cosine of 2 alpha. Now I don't have to do any work, and the reason I don't have to do any work is because I have several choices for the cosine of 2 alpha. The first one is the cosine squared alpha minus the sine squared of alpha. If I use that one, then I need both the cosine and the sine. I'm not going to use that one. This is also equal to 1 minus 2 the sine squared of alpha. I already have the sine of alpha, so that's the one I'm going to use. So this is going to be equal to 1 minus 2, 8 over 17 squared. So this is going to be equal to 1 minus 2 multiplied by 64 over 289. And so they want the exact value, so I'm going to have to multiply 2 times 64. Excuse me, sorry. Oh, that snuck up on me. Sorry about that too. So this is going to be 1 minus 128 over 286. And then, of course, I need to multiply this fraction here by 286. So I'm going to end up with 286 minus 128 over 286, which is equal to, let's do that in my calculator really fast. That's not what I can do in my head necessarily. I probably could, but 161 over 286. And that is my final answer. Now what we're going to do is look at the half angles. So if I have an angle and divide it by 2, I can use the plus and minus. I just need to make sure I know where I land, whether I take the positive or the negative of it. And then the cosine of alpha over 2, again, I need to know if I'm going to take the positive or the negative, except for tangent. Tangent kind of works itself out. And the way that I got from these values down, right, so how did I get this one, is I multiplied by the conjugate of the numerator, or I multiplied it by the conjugate of the denominator. So that's how I got those other values. Now, if I want to find the exact value using the half-angle formula, I want to think about what alpha divided by 2 gave me 15. And the answer is alpha must have been 30 degrees. So I can rewrite the sine using the half angles as 15 degrees as the sine of 30 degrees divided by 2. And then I can just go into the fact that this is going to be the square root of 1 minus the cosine of 30 degrees divided by 2, which is going to be equal to the square root of 1 minus the square root of 3 over 2 divided by 2. Now I'm going to go ahead and I'm going to go ahead and multiply numerator and denominator by 2 so I don't have a fraction within a fraction. And so I end up with 2 minus the square root of 3 over 4, which is just going to give me the square root of 2 minus the square root of 3 all over 2. Now, the reason that it is positive, why is this positive? Why did I choose the positive? Well, because the angle 30 over 2 is 15, and I land in quadrant 1, so I take the positive of that. Now I'm going to do the same thing with the next one. I'm going to take the cosine of 7 pi over 8. So I think of myself as, how did I get from alpha over 2 to be 7 pi over 8? So in other words, I multiply both sides by 2, and the alpha I would have started out with is 7 pi over 4. And that is where I should have started. So this is going to be equal to the cosine of 7 pi over 4 divided by 2. And I ask myself, where do I start? And that's going to tell me whether or not I take the positive or the negative of that. Let me just erase this. Whether I take the positive or the negative of my original problem. So this is equal to 7 pi over 8 is in quadrant number 2. That tells me I'm going to take the negative of the equation, because I would expect the cosine of 7 pi over 8, which is quadrant number 2, to be a negative number. So I'm going to choose the negative part. Now I'm just going to go ahead and evaluate this as 1 plus the cosine of 7 pi over 4 divided by 2. The cosine of 7 pi over 4 lands in quadrant number 4. So it's going to be a positive number, so it's a negative square root of 1 plus the square root of 2 over 2 divided by 2. And as before, I'm going to go ahead and multiply this by 2 and this by 2. And I'm going to end up with a negative square root of 2 minus or plus the square root of 2 over 4, which is the negative square root of 2 plus the square root of 2 all over 2. And now I'm going to do my last one, and I want to think of, again, alpha divided by 2 is equal to 75. Solving for alpha, I must have started out with 150 degrees. With this one, I have 3 choices, and I'm going to choose not the one that is the square root, the plus and minus. I'm just going to go right to one of these two so it shakes out nicely. I think I'll do the second one, just because I don't want to mess with the denominator being possibly not nice fractions. I'm just going to go right to the second one because cosine is in the denominator. So the tangent of 75 degrees is the same thing as the tangent of 150 degrees, which is the same thing as, I can just go ahead and find the tangent, but I'm going to do it this way. I'm going to have 1 minus the cosine of 150 degrees divided by the sine of 150 degrees. And so this is going to be 1 minus the square root of 3 over 2 divided by 1/2. I multiply everything by 2, and I'm going to end up with, in this case, 2 minus the square root of 3 over 1, and there's my final answer using the half angle, because I'm looking for the sine or the tangent of 75 degrees. The tangent of 75 degrees the tangent of 150 divided by 2. I should have put that divided by 2 there. And so I don't get to go the tangent of 75 is the tangent of 150. The tangent of 75 is 150 divided by 2, so then I can use the angle alpha being 150. All right. So then that leads us to, when do I take the positive and when do I take the negative? Well, I take the positive where I land. The fact that this angle is in quadrant number 3, I use the negative. The fact that this angle is in quadrant number, let me see, that's 12, 7, so that's quadrant number 3, I take the positive. The fact that this angle is in quadrant number 2, I'm going to take the negative. So you look at where you start out with to determine whether or not you take the positive part or the negative part. The next one we're going to look at is the power reduction formulas. So we have, or just reduction formulas. These are going to be really, really, really helpful in calculus. So sine squared of my angle is 1 minus the cosine of 2 theta. And basically all I've done here, by the way, is I have solved for sine squared. I took the double angle for cosine and solved for sine squared, or I've taken the double angle for cosine and solved for cosine squared. And then, of course, the tangent, I did the double angle for cosine and solved, that way. So if I want to do the power reductions, I can write this as the sine squared of 2x. So wherever I see the theta, I'm going to replace it with x. So theta is equal to 2x in this case. So this is going to be equal to 1 minus the cosine of 2 multiplied by my theta, which is 2x, all divided by 2. And so this is going to equal to 1 minus the cosine of 4x divided by 2, and that's all we want. That's all we want. Now I'm going to do the power reduction formula for this. I'm going to replace tangent squared with this. So tangent squared gets replaced with 1 minus the cosine of 2. My alpha happens to be x. My theta happens to be x. And then 1 plus the cosine of 2x. Here, theta is equal to x. Using this formula, my angle is x. Using this formula, my theta was 2x. Just keep it straight. Now I'm going to replace my sine squared. That is 1 minus the cosine of 2 theta. 2 theta divided by 2. And now what I'm going to do is I'm going to go ahead and multiply this. When I multiply it, the numerator is a difference of squares. So it's going to be 1 minus 2, it's going to be 1 minus cosine squared 2x, all divided by 2, 1 plus the cosine of 2x. Now here's the thing. We want to have powers of 1. That means I'm going to have to use the power reduction formula on just this one piece. So just this one piece needs to be replaced with 1 plus the cosine of my angle, twice my angle, so 2 times 2x, all divided by 2. So where we are now is we are at 1 minus 1 over 2, I'm going to write it as 1/2, 1 plus the cosine of 4x, all divided by 2, 1 plus the cosine of 2x. Now I'm going to multiply everything by 2 so I don't have that nested fraction. And when I get done, I'm going to get 2 minus 1 plus the cosine of 4x over 4, 1 plus the cosine of 2x. And of course, I'm going to distribute the negative through on the numerator and combine up like terms. So I end up with 1 minus the cosine of 4x. And then in my denominator, I'm going to get 4, 1 plus the cosine of 2x. And that's my final answer when I get done. So there is a power reduction formula, and I had to use it twice. You're going to see this in calculus. You're going to need to do the power reduction twice. You'll see that. All right, now let's prove these identities. So we know when we prove identities, we choose one of the two sides. I'm going to choose on this one, I'm going to choose the left side. Actually, you know what? I'm going to choose to do the right side. I usually do the left side. Let's choose the right side. And so I'm going to go ahead and write out the right-hand side. And I have -2, the sine of beta, minus pi over 2. Now, if you remember my cofunctions, right? That, first of all, the fact that I can rewrite the beta, if I pull out a negative, I can rewrite this as negative beta plus pi over 2, which is the same thing as a negative pi over 2 minus beta. So that tells me the sine of negative pi over 2 minus beta, using the fact that sine is an odd function, is equal to negative sine of pi over 2 minus beta. But this is a cofunction, so this is just equal to the negative cosine of beta. All right, so where I am now, this is equal to -2, the sine of beta, multiplied by the negative cosine of beta, which is simply just going to be 2, the sine beta, cosine beta, which using the double angle is just going to be the sine of 2 beta, which is equal to the left-hand side. Left-hand side, left-hand side, left-hand side. Okay, let's take a look at my next theorem here, or my next identity. I think I'm going to use the left-hand side on this one, even though it's got less terms. I have the sine of 4x divided by 4. I'm going to rewrite this as the sine of 2 multiplied by 2x divided by 4. And that way I can see it's the double angle. So this is going to be equal to 2, the sine of 2x divided by 4, and then multiplied by the cosine of 2x. The double angle is the cosine of 2x. Oh, I should have actually declared left-hand side. Don't forget to do that, left-hand side. Okay. Now you can see this 2 and this 4 will cancel into 2. So where I am now is I'm at the sine of 2x, the cosine of 2x, now divided by 2. I'm going to use the double angle here again, and so this is going to be equal to, using the double angle yet again, is going to be 2, the sine of x, cosine of x. And that replaces that. Now, I'm going to use the double angle for cosine, but I have to keep my eye on the prize. I want to have cosine squared, sine squared. So the replacement for cosine 2x is going to be cosine squared x minus the sine squared x. So this is going to be the cosine squared x minus the sine squared of x. And then we're still dividing by 2. Now you can see that my 2's will cancel, leaving me just the sine x cosine x multiplied by the cosine squared x minus the sine squared x. When I distribute this through, I'm going to get the sine of x cosine cubed x minus the sine cubed x, the cosine of x, which is equal to the right-hand side. Okay, so that was B. Let's take a look at C, and to do that I'm going to have to erase some of this, so give me a moment to erase all of this. So let me come back over here. Coming back over here. So I'm not going to do this one. I'm going to have you verify that one, and you're going to do it exactly like I just did with the cosine. You're going to start with the left-hand side. It's going to be so much easier if you start with the left-hand side. I am going to do D, so I'm going to start with, I'll do the right-hand side. Let's go wild and crazy right-hand side. So 1 minus the sine of 2 mu. So I know that 1, in general, 1 is equal to the sine squared of mu plus the cosine squared of mu. And the sine of 2 mu can be replaced with 2, the sine mu, cosine mu. Actually, you know what? Let me do this in a different color so it makes it easier to see that the sine of 2 mu can be replaced with 2 the sine mu cosine mu. And so this is going to be equal to, I'm going to replace this 1 with the sine squared mu plus the cosine squared mu. And then minus, I'm going to replace this with 2 the sine mu cosine mu. And now I'm just going to rearrange it. So this is going to be equal to the sine squared mu minus 2 the sine mu cosine mu plus the cosine squared mu. This has the form a squared minus 2ab plus b squared. That means that it is a perfect square trinomial even though it doesn't look like it. So this then becomes the sine of mu minus the cosine of mu, the quantity squared because it is a perfect squared trinomial, which gives me the left-hand side. So I chose the right-hand side. A little bit more involved than if I would have just chose the left-hand side. Left-hand side would have been so much easier, but I wanted to give you an option of what that looks like. Okay, let's take a look at this one. I'm going to choose the left-hand side. So I'm going to have left-hand side, left-hand side, left-hand. That's not what I wanted to do. Left-hand side. Left-hand side, which is 1 minus the sine squared of gamma divided by 2 over 1 plus the sine squared of gamma divided by 2, which is equal to 1 minus. Now, here's the thing. If I have the sine squared of theta, this is the same thing as the sine of theta, the quantity squared. Now, we talked about this before in class. So I can rewrite this as the sine of gamma divided by 2 squared, and then 1 plus the sine of gamma divided by 2 squared. And then now I can use my half-angle formulas. So, and it doesn't matter the plus or minus because I'm squaring it. So if we look at my half-angle formulas up here, it doesn't matter if it's positive or negative. Oh, that's a mess. The positive or negative up here, it doesn't matter because I'm going to square it. Because I'm going to square it, 1 minus the cosine alpha divided by 2 underneath the square root is just going to be 1 minus the cosine alpha. So 1 minus the cosine of my gamma divided by 2, and then 1 plus my 1 minus cosine of gamma divided by 2. Now again, let me tell you why. The sine of gamma divided by 2 is going to be plus and minus the square root of 1 minus the cosine of gamma divided by 2. If I square this and I square this, then the square root comes off and the plus and minus doesn't matter because it's going to be a positive number when you square it. So where I am now is I'm 1 minus the cosine of gamma over 2 over 1 plus 1 minus the cosine of gamma over 2. If I multiply every single term by 2, so that I can clear my nested fraction, I'm going to get 2 minus 1 minus the cosine of gamma. And then over here, I'm going to get 2 plus 1 minus the cosine of gamma. So in my numerator, I'm going to get 1 minus the cosine of gamma. And in my denominator, I'm going to get 3 minus the cosine of gamma. And that should be a plus in the numerator. And I have got, which side would I trying to do? I have the right-hand side. Right-hand side. Boom, boom, boom. Okay. Now I'm going to do G. And G is a really good one to do. And it doesn't matter which side you choose. If you choose, actually what I'll do is I'll tell you what, I'll start you out. If you choose the left-hand side, so left-hand side, and 1 minus 2, the cosine 2x over 1 minus 2 cosine x sine x. If you choose that side, you replace 1 with the cosine squared x plus the sine squared x. in both the numerator and the denominator. So both here and here. So if you choose that side. If you choose the right-hand side, then you have the sine of x plus the cosine of x. And then you have the sine of x minus the cosine of x. If you choose this side, my hint to you is multiply by the conjugate of the numerator. Sine x minus cosine x. Sine x minus cosine x. So there you are, starting you either way. Either way, if you start with the left-hand side, you replace 1 with cosine squared minus sine squared, and you're going to do like I did up here on D. If you are going to choose the right-hand side, you're going to multiply by the conjugate of the numerator, not the denominator for once, so it's going to be the numerator. Let's take a look at h. So with h, we want to find a common denominator. So if I choose the left-hand side, so I have 1 over the sine, make sure I've got it right, 1 over the cosine of theta minus the sine theta, minus 1 over the cosine theta plus the sine theta. Then my lowest common denominator to be able to add these two fractions is going to be the cosine theta minus the sine theta multiplied by the cosine theta plus the sine theta. Now remember, we are not clearing fractions. We are not clearing fractions. All we're doing is making common denominators, so don't clear your fractions. So that's how you're going to do it. That's my hint to you if you're going to do it the left-hand side. If you're going to approach from the right-hand side, which I don't recommend because there's more terms on the left-hand side, but you can do it this way. So 2 the sine theta over the cosine 2 theta. And then what you're going to do is you're going to break this part as 2 the sine theta, and then you're going to do the cosine theta squared minus the sine squared theta, and then you're going to break it apart here, and you will get to the other side. Either way. Anyways, that's it for this section, and we'll see you in class.